2.4.3c asks, for which values of c will the following system be inconsistent? If you remember, inconsistent means there's no solution to the system. So we're looking for a value of c, and we have some choices given for which our system will not have a solution. So there are two ways to do this problem. We can either use the concepts from Chapter 1 or Unit 1, row reduction, Gauss-Jordan, or from Chapter 2 or Unit 2, which had to do with determinants. Now if you haven't studied that far, then certainly just skip the last part of this video. You can always come back to it after you've done the rest of Unit 2. So if we want to do it like the last chapter or the last unit, we want to set up an augmented matrix. So the coefficients, that's the first matrix, 1, 1, 1, negative 1, 0, 4, 1, 2, c, and then the constants would go over here on the right side, negative 1, 3, 4. So I just turned my system into an augmented matrix. I want to start reducing it. And if you remember, my first step is to get a 1 in the upper left-hand corner, which we already have. Then I want to get a 0 below it, and then a 0 below that. So I want the first column to be 1, 0, 0. So those two steps that I need to perform are row 2 plus row 1, because that would be negative 1 plus 1, that would give me a 0. And then row 3 minus row 1. So that would give me 1 minus 1, which would also be a 0. So I continue all the way across. So I add row 1 to row 2 all the way across. That gives me a new row 2 of 0, 1, 5, 2. And then if I do row 3 minus row 1, that gives me a new row 3 of 0, 1, c minus 1, 5. Now I could then continue on like we normally do, which is to get a 1 in the 2, 2 position, which we already have. Woohoo! And then get a 0 above it and below it. Now, but I'm just going to be spinning my wheels if I try to get a 0 above it. So I'm not going to do row 1 minus row 2 because that's not necessary to solve the question. I am going to do row 3 minus row 2 because that's going to give me a 0 in the 3, 2 position, the third row, second column. So if I do row 3 minus row 2, that gives me a 0 in that in the correct location. So my third row becomes 0, 0, c minus 6, 3. And in order to have no solution, I would need for that last row to be 0, 0, 0, not 0. So in other words, if c minus 6 is 0, that would give me the system 0, x1 plus 0, x2 plus 0, x3, I should have said, equals 3. And that is an inconsistent system. So we want c to be 6. That would make the system inconsistent. Now the second way to do this problem is to use the concepts from 2.7 and 2.8. 2.7 is about determinants. 2.8 has to do with inverses. So if you haven't studied that far, you can always come back to this part of the explanation later. So let's find the determinant of that coefficient matrix. 1, 1, 1, negative 1, 0, 4, 1, 2, c. And we're going to set it equal to 0. We want to set it equal to 0 because there's a theorem that says if A is invertible, then AX equals B has a unique solution. It has some determinant other than 0, and that would mean there's a unique solution to the system. We don't want a unique solution. We want no solution. So we don't want A to be invertible. That means we want its determinant to be 0. So I'm just going to calculate the determinant along row 2. I chose row 2 because it has a 0 in it. You can go along any row or along any column. If I go along row 2, I do the element in the second row, the negative 1, times negative 1 to the power of the row plus the column. So that's negative 1 to the power of 2 plus 1. Then I eliminate that row and column. That gives me a 1, 1, 2, c. and then plus, and then I had that 0 in the second location, so that'll be 0 times whatever. It doesn't matter what the cofactor is because I'm going to multiply it by 0. And then last I would do plus the 4, which is the element in the second row, third column, times negative 1 to the location of that, which is the second row plus the third column, so 2 plus 3. Then I eliminate that row and that column. That gives me a 1, 1, and then 1, 2. And then I do the little determinants of the 2 by 2's. So I'll have the negative 1 here times a negative 1 there will give me a positive 1. Then 1 times c minus 2 times 1. So that's 1 times parentheses c minus 2. And then plus, and then 4 times negative 1 is negative 4, times 1 times 2 minus 1 times 1. So 2 minus 1 is 1. And so that's going to give me then c minus 2 minus 4. In other words, c minus 6. Remember, I want that to be equal to 0, so c minus 6 equals 0 means c is 6.